Hello everyone. In today's video, we're going to be answering questions on Northwest Regional Mock 2022 Chemistry Paper 1. If you haven't subscribed, please consider it so that you won't miss any of the future videos. So let's get right into the video. Question number 1. The relative atomic mass of an element can be defined as... So what do we know about relative atomic mass? This is the average mass of one atom of an element compared to 1/12 the mass of carbon-12 isotope. So from these options, we see that the best definition that gives us is D, which says the average mass of an atom of an element relative to 1/12 the mass of a carbon-12 isotope. So our correct option is D. Question number 2. Which of the following equations represents the second ionization energy of magnesium? Now, in order for us to have second ionization energy, we must have had first ionization energy. By the way, what is ionization energy? This is the energy required to remove a mole of electrons from a gaseous atom to form a positive gaseous ion. So, we talk about ionization of magnesium gas, which will give us a magnesium with a plus charge plus an electron. This is first ionization energy. Now when it undergoes second ionization energy, we have magnesium plus and the second electron being removed to form magnesium 2 plus another electron removed. So this is actually the second ionization energy of magnesium, from plus 2 plus 2, and our best option is option B. Question 3. The half-life of protactinium is 28 days. How long will it take for the radioactivity of protactinium to reduce to 1/16 of its initial value? So they've given us the half-life. And what is half-life? Half-life is the time taken for the activity of a radioactive sample to fall to half its initial value. So we are told that we should calculate the time taken for it to fall to 1/16. It means that before the activity starts decreasing, it is at a maximum of 1. As time goes on, at time t half, it reduces to half, which is half-life, and another t half, it reduces, this half reduces again by half, giving us 1/4. And in another time t half, this 1/4 reduces again by half, we have 1/8. And another time t half, this 1/8 reduces again by half, we have 1/16. Therefore, we are going to say that there are 1, 2, 3, and 4 half-lives consecutively. Therefore, total time t is equal to 4 times the half-life, which is t half, which will be equal to 4 times 28. And 4 times 28 gives us 112 days. So our time for the activity to reduce to 1/16 is 112 days, making option A to be the best. Question number 4. An organic compound of relative molecular mass 150 contains the following composition by mass: 32% of carbon, 4% hydrogen, and 64% oxygen. Its empirical formula is... So let's analyze this problem. So these are the elements. We are going to divide each percentage by the relative atomic mass of each. So we are going to have 32% divided by the relative atomic mass of carbon, which is 12. We have here hydrogen is 4% divided by the relative atomic mass, which is 1. Oxygen is 64% divided by the relative atomic mass, which is 16. So our result here is going to be, so we have this result, and we're going to divide by the smallest ratio, and the smallest ratio here is 2.667. So we divide all through by 2.667, and our result is going to be 1. Here is approximately 1.5, 1.5, and since it is 1.5, we can neither round up nor down, but we multiply all through by a factor of 2, so that we are going to have resulting 2, 3, 3, and therefore our empirical formula will be C2 H3O3. This will be our empirical formula, and our answer becomes B. Question number 5. Copper has atomic number 29. The electronic configuration of copper 1 ion is electronic configuration of copper 1. It means that copper has lost 1 electron. So argon core is represented as 1s2, 2s2, 2p6, 3s2, 3p6. So this is a representation of the argon core. And for copper, since it has atomic number 29 and has lost 1 electron, it ends up having 8 electrons. So we're going to have the argon core now going to the 3d and going to the 4s. Now, what is going to be our feeling here? We see that the argon core is already comprising of 18 electrons. The summation of 2, 2, 6, 2, 6 gives us 18. And we need, since it has lost 1 electron to become 28 electrons, we need 10 more electrons to have a stable structure. So when ions are being formed, electrons are first removed from the s subshell before being removed from the d. So when it is not yet an ion, we will have 1 here, s1 and d10. Now this is the most simple structure. If it loses now an electron, the electron is lost from this, so that we are going to have this. So this will be our answer, and our correct option here is D. Question number 6. Which property increases with increasing atomic number for both alkali metals and the halogens? We talk about A. Ionization energies. Actually not. Ionization energy increases across the period and decreases down the group. Therefore, ionization energy cannot be the best. B. Melting point. Melting point is not true. Melting point of the alkali metals actually decrease down the group due to decrease in metallic bond strength. Electronegativities, which is not true. Our correct option here is atomic radii. Atomic radii for each of the elements increases as we move down the group, because new shells keep adding as we move down the group, thereby increasing the atomic size. So D is our best option. Question 7. Question 7. Which of the following statements about the halogen group is correct? A. First, ionization energy increases from fluorine to iodine, which is not true. Ionization energy decreases down the group due to the fact that electron shells are adding, and the ease with which an electron can be removed also increases. Therefore, it instead decreases, making A false. B. Fluorine has the smallest tendency to be reduced. Is that a true statement? Fluorine is said to be a high or a powerful oxidizing agent. So it oxidizes another species and itself becomes reduced in a reaction. Therefore, the higher its oxidizing power, the more easily it can be reduced, which makes B false. C. Chlorine will oxidize iodine. D. Iodine is a stronger oxidizing agent than fluorine. So we are seeing that C is our best option, because for the halogens, oxidizing power decreases down the group. So chlorine will be able to oxidize the iodide, making C to be the correct answer. Question number 8. Identify the type of organic reaction involved in the reaction below. We have benzene reacting with chlorine to form chlorobenzene. So in this reaction, benzene undergoes predominantly electrophilic reactions because of the already existing delocalized pi electrons around the ring. So it undergoes predominantly electrophilic reactions. So in the reaction, chlorine is going to react with the halogen carrier, aluminum chloride, to form a chlorine electrophile, which will be the one to attack the benzene ring, forming chlorobenzene. So our best option is electrophilic substitution reaction, because a hydrogen atom will be displaced as the chloride comes in. So our best option is B. Question number 9. The shapes of the carbonate and chlorate ions are respectively. So let's try to analyze out the structures and shapes. So from the structures, we can draw their dot and cross diagrams of the carbonate. Since it is carbonate, it means that it receives 2 electrons, and these are the 2 electrons that are here. For the dot and cross diagram, we have this. Now the structure becomes this, where there is no lone pair between the carbon atom, and as a result there is even repulsion between the bonded pairs, giving rise to a trigonal planar shape. Unlike for the chlorate, which has a lone pair of electrons on the chlorine atom, now tending to this lone pair of electrons now tends to pull the bonded pairs towards each other, giving rise to a pyramid, hence the name trigonal pyramida. So our best option we can see here is A. The carbonate is trigonal planar and the chlorate is trigonal pyramida. So A is the correct option. Number 10. Which force of attraction is responsible for the dimerization of ethanoic acid? So for dimerization, a dimer simply is a molecule that is made up of identical smaller molecules combined. So if we have ethanoic acid, the dimer will be when it combines. So the dimer will be 2 times it. So a larger molecule made up of 2 identical smaller molecules. So hydrogen bonding is responsible for the dimerization of organic acid. We have D to be our best option. Question number 11. Which row correctly shows the type of mechanism of each of the 2 reactions? We have bromoethane reacting with potassium cyanide, and we have propanone reacting with hydrogen cyanide. So let's write down the 2 equations. So between these 2 equations, the first equation, we just simply have the replacement of the bromide with the cyanide. It is called nucleophilic substitution, because the cyanide is a nucleophile that comes and replaces the bromide, called nucleophilic substitution. And in the second one, we see that the cyanide simply adds itself to the ketone. So this one is cyanide, still a nucleophile, but this is nucleophilic addition. So our best option is D. Question number 12. How many isomeric esters have the molecular formula C4H8O2? This compound. So let's analyze the structures by drawing all the isomers. So these are the open structures of the isomers. Isomers, that is isomeric esters of this general formula. So we have 1, 2, 3, 4. So it means that there are 4 isomeric esters of this formula, and our best answer is C. Question 13. PVC is used as a packaging material. What holds the different polymer strands together in a piece of solid PVC? PVC means polyvinyl chloride. So it's a polymer of vinyl chloride, where the chlorine atoms are larger and rarely come together. So predominantly we have van der Waals forces that hold the different strands together. So D is our best response to this. Van der Waals forces are involved. Question 14. Calculate the pH of 0.2 molar propanoic acid with Ka 1.26 times 10 to the minus 5. So since propanoic acid is a weak acid, it has an acid dissociation constant. And so to calculate hydrogen ion concentration in solution, it will simply be the square root of the value of Ka dot the concentration in molar. Therefore, hydrogen ion concentration is going to be equal to the square root of 1.26 times 10 to the minus 5 times the concentration 0.2. So hydrogen ion concentration is going to be equal to 0.0015. Now, in order to calculate for the value of pH, what we know is pH equals minus logarithm of hydrogen ion concentration. So pH will be equal to minus logarithm of 0.0015. 5. So our pH value is going to be 2.799, which is approximately 2.8, making our answer A to be correct, which is the pH of propanoic acid. Question number 15. Which of the following statements is true? A. All oxides of S-block elements are basic, which of course is false because beryllium oxide is amphoteric. B. The thermal stability of the carbonates of the S-block element increases down both groups 1 and 2. That is a true statement due to increase in atomic size. So C. The solubility of group 1 sulfate decreases down the group while that of the group 2 sulfate increases. No, that's not a good statement. D. Beryllium and magnesium both react with water to form basic hydroxide. That's not true. So our best option is B. The thermal stability increases down both groups due to increase in atomic size. Question 16. Which of the following mixtures will show negative deviation from Raoult law? So from Raoult law, negative deviation means increase in temperature upon mixing the two solutions. So when we mix ethanol and water, there's a decrease in temperature. We talk about positive deviation if there's a decrease in temperature. For benzene and methylbenzene, they are actually close in molecular weight, so they tend to behave ideally. C. Methanol and ethanol are also ideal solutions. They form an ideal mixture. So inorganic acid like nitric acid and water will evolve heat when mixed. So all inorganic acids when reacted with water will produce heat, and when heat is produced, it means the temperature increases, hence negative deviation. So our answer is D. Question 17. A sample of element X is analyzed using mass spectrometry. The mass spectrum obtained is shown. We have relative abundance versus mass per unit charge. So we have different peaks corresponding to different isotopic masses. So they ask, what is the relative atomic mass of this sample of element X? So in order to calculate relative atomic mass, we are going to talk about the product of relative abundance and the isotopic mass and take their sum for all the peaks divided by the relative abundances. Let's see the expression. So this is the expression we have, and our relative atomic mass now will be given as 114.35, which is approximately 114.4. So our best option here is going to give us D. Question number 18. An indicator changes color in the pH range 8.3 to 10.0. This indicator should be used when titrating a known volume of. So we see that the equivalence point lies within the basic zone. It means that the base should be stronger and the acid should be weaker. That is why the equivalence volume is actually at the basic zone. So trying to sketch it, we have something like this. So the curve actually shows something like this, where the equivalence volume falls but in the basic zone. It tells us that the base has a higher strength than the acid. That's why at equivalence point it is found to be in the basic zone. So the best reagent that can be used here in this case is going to be a weak acid and a strong base, which makes D to be our correct answer. Question number 19. The standard enthalpy change for the reaction nitrogen fluoride giving us nitrogen plus fluorine is 1668 kilojoules. What is the bond energy of the NF bond? So in order to calculate bond energy, we simply need to talk about enthalpy of reaction. Enthalpy of reaction given different bond energies equals the sum of the bond energies of reactants minus the sum of the bond energies of products. So in this case, we look at the reactants and the products. So for the nitrogen fluoride, we have nitrogen to fluorine 3 bonds, and there are two molecules of nitrogen fluoride. So there would be altogether 6. Then we look at the products. We see that they are all individual atoms. It means that there is no bond involved with the products, so bond energy is 0 for the products. So we are going to have enthalpy of reaction now to be equal to 6, the energy of nitrogen to fluorine, minus 0. Minus 0 because there is no bond for the products, but they are individual atoms. So 6 energy of nitrogen to fluorine equals enthalpy of reaction. Therefore, the energy now for the nitrogen to fluorine bond will be equal to enthalpy of reaction divided by 6, which is equal to 1668 divided by 6, and our answer is going to be plus 278 kilojoules per mole. That would be our value, and our option here is C. Question 20. Given a cell composed of the following half cells, copper 2 plus going to copper 1 with the corresponding electropotential value, they are asking us which of the following species is the strongest reducing agent. Now let's take note of this. In order to identify the half cell where there is the strongest reducing agent, we are going to check the electropotential values. The half cell with a lower electropotential value will contain a species which is the strongest reducing agent. So we look at this between these two electropotential values. This one is a lower electropotential value. This one is a higher electropotential value. So therefore, we are going to obtain the strongest reducing agent from the first half cell, and the oxidizing agent can now be obtained from the second half cell since it has a higher electrode potential value of 0.54 volt. So a reducing agent is a species which becomes oxidized in a reaction. So in a normal sense, if we look at copper 1 and copper 2, it means that from copper 1 to copper 2 there is oxidation. So in the first half cell we talk about oxidation. So since it is the anode, oxidation takes place at the anode. So rewriting equation 1, we are going to have copper 1 going to give us an electron plus copper 2 plus. This one now is oxidation from copper 1 to copper 2. So copper 1 is a reducing agent because it is oxidized to copper 2 in the reaction. So therefore our most powerful reducing agent is from the first half cell, which is copper 1 plus. So the most powerful oxidizing agent could also be obtained from the half cell with a higher electrode potential value. So if we look at this second half cell, a species which becomes reduced is called an oxidant. So if we look at iodine being reduced to iodide, iodine becomes a strongest oxidizing agent in this case. So that is the end for this session. If you did enjoy the video, give it a thumbs up. Don't forget to subscribe, comment and share. See you in the next session. Thanks for watching.